Hello and welcome to section 1.6 inverse functions. And so basically this is just some basic notes for it. You probably have done some inverse functions before, but if you haven't, when we're going to solve for an inverse function, basically we're switching the x and y's places in the original function, and then we would solve for the other one. And basically what this gives us is that this gives us an inverse function would be symmetric about the y equals x line. So it's this diagonal line that cuts across the coordinate plane that gives us where we are symmetric about for the inverse function. So f of x will be flipped over this y equals x line to give the inverse. And so the connection between the domains and ranges are this. If we have the domain of f of x is the same as the range for the inverse of f of x, while the range of f of x is the same as the domain. So going back and putting this in a little bit different terms, the x of the f of x is the same as the y, and the y is the same as the x. And so we're just kind of flip-flopping these places, and that's how we will solve for the inverse when we get there. And so then we have to determine if there is an inverse of the function, then we use what we call a horizontal line test. And so if I have a function that is like a parabola, if I have a parabola drawn and I do something like this, there is technically, by the horizontal line test, there is no inverse function. Now, because there's no one function that can be written to give the inverse of this. Well, there is an inverse for the square root, but you have to use two different functions to do it, so there really isn't an direct inverse from this function. Now, the cubic function, on the other hand, which would look something like this, the cubic function could be flipped over. Since the cubic function looks kind of like that, it could be flipped over the y equals x line, and the y equals x line would be a dotted line, something like that, and it'd be flipped over, and it's going to be the complete opposite of it, and it's going to go something like that, which would give us our inverse of our cubic function. So the inverse is, and if you look at the cubic function, the blue one that I drew originally, would pass the horizontal line test. So what happens here is a function is one-to-one if we have f of a equaling f of b, and it's important that in its domain that this happens for the inverse function. And so a function has to be one-to-one before you have an inverse, and the inverse then is also one-to-one to have a function. And so they were just kind of flip-flopping back and forth between those, so please make sure that you get this down. And then my one example for this is that we are going to find the inverse of this function. So we really have f of x equals 5 minus 3x over 2. Well, remember that for the inverse function, the inverse function is the x and y switch places. So what I'm going to do this, I'm going to call f of x y, so my function could be written like this. Same thing, but if I want to write the inverse, I'm going to switch the x and y's places. So to find the inverse, I'll move over here and say that x is equal to 5 minus 3y over 2. Now, to actually get the inverse function, I need to solve for y. And so that's what I will do. I'm going to get rid of the division by 2 by multiplying both sides by 2. Multiplying and dividing by the same number become 1. And so I have 2x equals 5 minus 3y. If I then, to get the y by itself, I'm going to have to subtract 5 across the equal sign. And remember, I'm not really subtracting 5 from the 2x. I just get 2x minus 5. I'm not going to reduce that number any, and equals negative 3y. And then I divide everything by negative 3. And you can just leave it like this. You don't need to go to any other kind of fractions. My y, my inverse function, is well, you can go 2x minus 5 over negative 3, or you could move the negative up to the top, which distributes throughout the top, and so you'd get negative 2x plus 5 over 3, or even flip-flopping the 5 and the negative 2x might be a way you'd see it. 5 minus 2x over 3 would be the inverse function of this. And so if you were to graph these, you could see that they were inverse functions. And so that's one of the things we can do. Let's get them on our graphing calculator here and just show you that they're flipped over the line y equals x. And so if I was to graph the original function, I'm going to say 5 minus 3x all divided by 2. And so there's that line. And if I draw the other one, so now let me move this over here real quick. I'm going to grab this one, put it right here. So there should be a dotted line, or should be a line that we're going to flip across the y equals x right here, that I will flip this line over. And so by flipping it over this line, the x and y switching places, then we'll get the inverse function. And so let's put the inverse function in here, and we'd get negative 2, oops, I need parentheses here, 5 minus 2x, I'm just flip-flopping it around, divided by 3. And so now when I graph it, I get this other line, and let's turn off the first one just so we don't have it anymore. And so there's my inverse function, so I'll move it over here. And if well, let's do this. I'm just trying to show you that this is, oops, wrong thing. Oh. Well, I just wanted to make it a little lighter, but I wanted to set it over the top of this one so you could kind of see what was going on. But so you could see that it flipped over the line. But maybe you can kind of tell from here that this has been flipped over, this purple line that I drew in there. And so that's really all we're talking about when we're dealing with inverses, is that we're going across the y equals x, and the x and y switch places. Maybe a table of values would be a better. You could see the table of values. Let's do that one real quick. And I need turn this one on. So let's look at the table of values. And so you can see that when I'm at negative 3, I'm at 7. If I went down to 7, you could see that I'm at negative 3 for the other one. And so you can kind of see how these are flip-flopping places. And so we just need to kind of pay attention as we're doing this, that we're going to switch the x and y places to get the inverse. If you have any questions about this, please come to class prepared to ask.